In this video, we're going to be finding a polynomial with given zeros. But first, let's talk a little bit about the complex zero that occurs in conjugate pairs. So if we let f be a polynomial function that has real coefficients, then if a plus bi, where b doesn't equal 0, is a zero of the function, then the conjugate a minus bi is also a zero of the function. So let's do a little bit of an example, and that'll help. So here we're going to find a fourth degree polynomial function with real coefficients that has -1. Oh, looks like we have a little bit of a typo. Let's get rid of that and let's put the -1 over there. So -1, -1, and 3i as zeros. Now 3i is a complex number. So if 3i is a 0, then that means -3i is also a 0. So we're going to start off by writing these as factors. So if x equals -1, that came from x plus 1. So we'll have x plus 1 for this one. We'll have an x plus 1 for this one. We'll have an x minus 3i for this one. And we'll use an x plus 3i for this one right there. So now that we have that, we're simply going to multiply them out. And so for this first one right here, we're going to go ahead and we're going to FOIL that. And when we FOIL that, so we're going to get x squared plus x plus x plus 1. So x squared plus 2x plus 1. Now over here, because these are conjugates, we can just take the a squared minus the b squared. So we'll have x squared minus 3i squared. So x squared minus 9 times -1, or x squared plus 9. And so now we need to take and multiply this piece with this piece. Oops. So we're multiplying those pieces together. So I'm going to go ahead and show that with a darker blue and a darker green. So we'll make that x squared plus 2x plus 1 times x squared plus 9. So I'm going to multiply my x squared. Let me move this down a little bit so I've got a little bit of room to work. Okay, oops, that didn't want to come with. That's all right. So the x squared times x squared is x to the 4th. And then x squared times 2x is going to be a 2x to the 3rd. And x squared times 1 is going to be x squared. Then I'm going to go ahead and multiply the 9. So I'm going to have 9 times x squared is a 9x squared. 9 times 2x is going to be an 18x. And 9 times 1 is going to be a 9. And now I'm going to combine my like terms. In combining my like terms, there isn't really anything with the x to the 4th, so x to the 4th. The x to the 3rd is by itself as well. But I do have a 1 plus 9 for my x squared, so plus 10x squared. And the 18x is by itself, and the 9 is by itself. And now I can say that I can have f of x. Oops. Let me just scoot this over a little bit, because we're not quite done. So that's what I get from that. However, any multiple of this will work. So it's actually f of x equals a times x to the 4th plus 2x to the 3rd plus 10x squared plus 18x plus 9. So we're just going to go ahead and we're going to let a equal 1, which will give us our final answer of f of x equals x to the 4th plus 2x to the 3rd plus 10x squared plus 18x plus 9. And so that is a 4th degree polynomial that has real coefficients of x equals -1, x equals -1, x equals 3i, and x equals -3i. So those are our imaginary ones. Now, so when are you not going to let a equal 1? And that's going to be our next example. So what I first want to do, though, is kind of point out what we did. So we wrote as factors, then we multiplied. then multiplied. All right, so let's try this next one. So now we're going to find a cubic polynomial, right? So cubic, so it'll be x to the third with real coefficients that has a 2 and a 1 minus I as zeros. And then we're supposed to find our f of 1 equals 3. Now this is going to tell us that our a value might not necessarily be a 1. And we'll have to figure out what that value should be. But that's something that we do at the end. So right now we're going to see that we have a few different values. We have a 2. We have, let's try that again. So we have 2. We have a 1 minus I, which means that technically we also have a 1 plus I. So let's write these as factors. So we're going to have x minus 2. We're going to have x. This one's actually going to be a little bit different because we have a 1 minus I. So it's going to go x minus 1 minus I. And then we're going to have an x minus a 1 plus I. Okay. So now what we're going to do is we're going to multiply this right here. Now I know it looks really messy and like, oh my gosh, I'm so confused. How do I do that? And it's actually not going to be that bad. All right, so we're going to start off and I'm going to take my x times x, which is x squared. Then I have an x times a negative 1 plus I. So that's going to give me an x. So a negative x times 1 plus I. Then I'm going to have my negative 1 minus I times x, which is going to give me a negative x times 1 minus I. And a negative times a negative is a positive, and I minus a 1 minus I, and a 1 plus I. And so that one we might need to write down. So if we take our 1 minus I and we multiply that with our 1 plus I, which we know to be conjugates, so we have our a squared minus our b squared, then we're going to have our 1 squared minus our I squared. So we're going to have 1 minus negative 1, or a 2. And so a negative times a negative is a positive, so here we'll put plus 2 right there. All right? All right, so now what we're going to do is we're going to distribute these values inside. So now we have x squared minus x minus xi. And over here we have a negative x and a plus xi. And then we have our plus 2. And then we're going to combine like terms. So the x squared's by itself. I have a negative x and a negative x, which is going to give me a minus 2x. I have a negative xi and a positive xi, which will cancel each other out. And then my plus 2 is by itself, so plus 2. So it looked way worse than what it really was. You just need to kind of break it down and make sure you write down all of your steps so you don't get lost, okay? So now we're going to take this, and it still needs to be multiplied with x minus 2. So we're going to go ahead and we're going to distribute our x to all three things. Get an x to the third minus 2x squared plus 2x. Then we're going to multiply our negative 2 to all three pieces. You get a negative 2x squared plus 4x minus 4. I'm going to combine our like terms. And this is going to give us x to the third minus 4x squared plus 6x minus 4. So that means we have f of x equals a times x to the third minus 4x squared plus 6x minus 4. And now this is where our green piece is going to come in, because if f of 1 is going to be a 3, then that means our a value isn't going to be a 1. So what we're going to do is we're going to rewrite this and say, okay, f of 1 equals a times, now everywhere we see an x, we're going to take the x out and we're going to replace it with the number 1. Okay, right there. So all of those need to become a 1. So we're going to go ahead and we're going to plug a 1 in just like it asked us to do. Then remember that it said f of 1, right up here, f of 1 is 3. So if f of 1 is 3, then that means that this value right there is actually the number 3. And now we're going to solve. So we have 3 equals a times 1 minus 4 plus 6 minus 4. So now we have 3 equals, and we're going to go ahead and do the math of 1 minus 4 plus 6 minus 4, which is going to give us a negative 1. So we're going to have a times negative 1, which gives us a negative a. So we're just going to go ahead and write down negative a. And I need to have the a by itself. So if I need to have the a by itself, then I'm going to need to multiply both sides by a negative 1, or divide, however you want to think of it. So that's going to tell me that negative 3 is my a value. So I can now write my equation, and I'm going to take my negative 3 and I'm going to plug it in. So negative 3 times x to the third minus 4x squared plus 6x minus 4. And we're almost done. I know this is a long problem, but then our last step is to distribute that negative 3 to all of these pieces to get our final answer of f of x equals negative 3x cubed plus 12x squared minus 18x plus 12. And that is our final answer. And so now you know when your a value is not going to be the number 1, what you'll need to do and how to know.